right, so let's take a look at this computer number systems problem. Of course, that's going to be your binary, your hexadecimal, your octal, and then decimal will be part of that as well. Okay, so in this case, evaluate the following expression and express the answer in octal. Let's not forget to do that. Really a couple ways to do this. You can convert these all to decimal, do the math, and then convert it back to octal. Again, that's okay. Sure, we can do it that way. Just knowing that when we have octal, that these are ones, these are eights. So we have 1 8 and we have 3 1s. So this is just going to be 11. Okay. And then we have, so I'll just separate these, right? And then we have A3, which is base 16 or hexadecimal. So we know that these are going to be ones, these are 16s. So we have A16. In other words, we have that A represents 10. So we have 10 16s and we have 3 1s. So we have 160 here and then 3 more 1s here. So 163. And then we have, I'll do the last one over here. So 1 1 0 1 in binary. Well, that's an 8, right? Because we have 1 2 4 8. So that's an 8, a 4, and a 1 here, right? Which again is just going to be 13. 8 plus, we have again an 8, a 4, and a 1. So we know that's just going to be 13. So if we do sort of 11 plus 163 minus 13, we get 161. So this is 161 in decimal, right? Base 10. So that's not what we're looking for, right? We do need to express the answer in octal. So to convert here, we're going to have to figure out sort of how many. We're gonna figure out octal places. So our octal places are going to be our ones. In other words, our 8 to the 0. 8 to the 0, which is just ones. We have 8 to the 1, which is just 8. And then we have 8 squareds, right, which is our 64s. We shouldn't, I don't think, need to go beyond this in this case. So, okay. So we're thinking how many 64s go into here. So one of them is 64. Would be 128. So in this case, we know that it's going to be 2, right? Because there's not going to be one more, would be like 180 plus, right? So 192 actually. So it would be bigger than this. So we know that so 128 is going to go into this. So 128, right? So we can represent two 8 squareds, 2 64s in our octal number. It's going to be there, right? Is going to be represented by this 128. Okay. Then basically we can do the subtraction. Again, we're going to have to do this by hand or in our brains is fine, but we end up with 33. All right, so we have 33 left. So how many 8s go into 33? Well, we should know that we have 4, right? Because 4 times, this is where it gets easy because that's going to be, of course, 32. We have 1 left, so how many 1s? 1, right? So our answer is going to be this, 241. That's base 8, or an octal is what we're looking for, 241. Okay, that's one way to do it. We could do it in a second way. Yeah, let's see if we can do this in a second way while we're at it, because why not? I'm just going to see if I can copy and paste a whole new one in here and get rid of all the... nope, that's not it. So there it is. Okay, so let's see if we can just get rid of all this stuff. Okay, we got rid of everything. Good. Okay, so again, we might, because we're dealing with octal, we might just want to keep everything in binary if we can, because it's kind of easy to convert octal, hex, and binary, of course, to binary, and then we can just group them into groups of 3s for octal. I haven't done it this way yet, but let's see if this works out. So we can do this. We know that 1, of course, is 0. In groups of 3s is 0, 0, 1, or just 1. And then, of course, 3 is just going to be 0, 1, 1. Right? So we really can just say that this is going to be 1, 0, 1, 1. We can break this one down into 2 groups of 4 bits here. So this A is going to be 10, which is going to be 1, 8, 1, and 1, 2. So 1, 0, 1, 0. And we have 3, which is going to be 0, 0, 1, 1, right? A 2 and a 1, right? Represented in 4 bits here. And then we have, of course, that is just going to be itself. So I don't have to do anything with that yet. So I'm going to add these and subtract these. I guess I could subtract them and add, but let's do the addition first. So if I take this value and I add it, we're adding 1, 1, 0, 1. I'm doing the addition. So 1 plus 1 is 2. And remember, 2 in binary is like this. So we actually have to carry the 1, but so that's going to be like, there's 1, 2, but 0 ones, right? So that's how we're going to have to add there. 1 plus 1 plus 1 is 3, but in binary, 3 is represented like this. That's 2 and that's 3. So we know that 1 plus 1 plus 1 is 3. So it's going to be a 1, and we have to carry that 1. 1 plus 0 is just 1. 0 plus 1 is 1. And then, of course, these will be the same. Okay. So now we have to subtract 1, 0, 1, 1, lining them up. Be careful to line them up. So subtraction's a little different. So in this case, if I have 0 minus 1, I can't do that. So I do have to borrow. So basically, I have to borrow over here. So I'm borrowing a 2 to put here. So I'm basically saying, all right, take this. And if I take away this, I take away that 2 and I move it over here. Well, this becomes basically 1, 0. But remember, 1, 0 is 2. So now we have 2 minus 1, which is 1. Okay, right, because obviously 1 would just be 1. Okay, so, and then we have 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 1 is 0. And then we have, of course, we can just keep the rest. Okay, so we have this. Now that's our final answer here, but we have to convert it to octal. So we group them here in groups of 3, basically. This one only has 2, but of course we can just add a 0 to finish it out if you want. So right here we have a 2. This is 4, and this is 1. So yeah, that works out the same, right? 2, 4, 1, base 8. Awesome. All right. So either way, of course, works. If you're good with binary, with sort of adding and subtracting and making sure you're careful to carry things during the addition and subtraction, it's not a bad way to do it at all. But there are 2 ways to do it. Actually, there's probably even more, but there were 2 ways to do it that I showed. Cool. Great. Grand.